Hello, Coach Holmes here, and today we're going to be talking about side-side-side similarity as well as side-angle-side similarity. Now, just like in the previous unit we talked about with side-side-side or side-angle-side, this principle can actually be used for similar figures, rather as well as congruent figures. We already talked about being able to find congruent figures or congruent triangles from side-side-side or side-angle-side. But this time, we're going to try to be able to use similar figures or similarity for side-side-side as well as side-angle-side. Now, what do we do with side-side-side similar theorem? If measures of the corresponding sides are proportional, then they're similar. Which basically means that if all three sides are similar, or at least they're proportional, they're similar figures. Okay? But that's given all three sides. If we're given three sides for both triangles, not only will it be side, 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 as long as the sides are proportional. Now, what about side, angle, side? Similar theorem. Simple. If two sides are proportional, and an angle in between are congruent, then they're similar. All right, so what that tells us is that if the two sides are proportional, as well as the given angle is in between being congruent, then we can say that the triangles are similar through side, angle, side similar theorem. That's what actually helps us out, is being able to recognize, or at least half the battle is recognizing is it side, side, side or side, angle, side. And then the second half is just determining if the sides are proportional, plus if the angle is congruent if we're given an angle. So, looking at this problem right here, I wanted to determine if these three triangles are congruent to each other. Now, just to make things simple, I'm going to label these as A, B, and C. So that way when I'm working them out, that way instead of saying like triangle STU, triangle BEN, I don't confuse you all with all those letters. I'm going to try to keep it simple by saying triangle A, triangle B, triangle C. Okay? So, if I want to compare triangles A and B, so I don't want to do the triangle, but if I do A and B, okay? I know that this length right here is proportional to here. So 20 over 8. There we go. Yeah, that's right. I was having a brain fart. Now, I also know that SU is proportional to BN, or at least it should be, or at least they're corresponding. That's a better word for it. I know those two are corresponding. So I'm going to say 30 over 12. Now, if I simplify that, if I simplify these two fractions, I am going to get 5 over 2. Well, hold on. Let me put it in green, so that way you know where it's coming from. 5 over 2 and 30 over 12 is 5 over 2 as well. So I know that these two triangles are similar figures from using side, side, side. Now, how does that compare for the other two? Like the other two possibilities? Well, the other two possibilities are B and C and C and B. C and A. Sorry. Those are the other two possible similar figures. Okay? Now, if I want to figure out if those two are, if I want to figure out if B and C are similar, all I gotta be able to do is be able to say that while BE is similar to JI, so I'm going to say 8 over 12, I'm sorry, not J, 12. And BN is similar or corresponding to JM, so it's going to be 12 over 16. Well, if I look at the ratio for it, well, the scale factor, I want to make sure. 8 over 12 simplified is 2 over 3. And 12 over 16 is simplified is 3 over 4. Well, they're not the same. So this one doesn't work. So these two triangles are not similar. Now, if I do triangles C and triangles A, well, I know JI is similar to ST, as well as JM similar to SU. Now, if I simplify the fraction, I get 3 over 5, and then 16 over 30, 8 over 15. Well, shoot, they're definitely not the same. So that doesn't work. So the only ones that are similar to each other is triangles STU, BEN. These two triangles are similar to each other from side, 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 similar theorem. Okay? That's what helps us out. Now, we want to determine if these two triangles are similar using side angle side. Okay? So that means that not only do I have two sides here, but look at these two angles. Not only are they in between the two sides, but since they're both right angles, they're congruent to each other. So I can use side angle side. But my question is, how are they proportional? Well, I know that LO and BU are similar, or corresponding, so I'm going to do 24 over 16. And I know that OV is corresponding to UG, 28 over 21. Now, I want to simplify both fractions. So this gives me 3 over 2, 28 over 21, over 3. Okay, so while we do have side angle side here, because these are not proportional, it not only doesn't work, but it's not similar. So there is that possibility where this may not work. Okay, so you have to be aware of the possibility of it not working. But just to be able to recap all of this, what we got to make sure to know is that the sides has to be proportional to each other. All right. If the sides are proportional to each other, we have similar figures. If not, then none of it can work. Thank you and have a good day.